So we were taking a look at different sedimentary structures that we can see, and in class last time we talked about crossbeds and ripple marks, but let's take a look at some other ones we can see. We can also see these things called turbidity currents and graded beds. Turbidity currents is where my sediment is going to basically roll down the continental slope and get deposited, and as it gets deposited, right, initially that water is moving very fast. So we're going to deposit very large-sized particle, but as that water continues to get slower and slower, we deposit finer and finer particles. And that's what we call a graded bed, right? Where you can see large particles on the bottom and smaller, fine particles that are sitting on top. We can also get mud cracks, right, which you can see here, right, which form essentially as our sediment is inundated with water and then it dries out pretty quick. Those mud cracks can actually get preserved in the rock record. We can also get scour marks, which is basically just done by where we've got, as you can see here, and of course down here we've got branches that are essentially being dragged along the bottom of the ocean. And then my favorite, right, we can see lots of fossils, and fossils are any evidence of past life. So let's take a look where sediment's going to get deposited. This is what we call our depositional environments. And there's many, many different kinds. There's literally hundreds of different kinds of environments of deposition. And that's basically just where my sediment's coming to rest, right? Where my water velocity is changing enough that my sediment is slowing down and it's getting deposited. So we're going to look at some common ones. We're going to first start looking at our terrestrial ones, which are the land-based ones. And the first one are the glacial environments, and this is just due to gravity pulling on ice. So as the ice moves over the ground, it picks up that sediment and material and entrains it in the ice. And so sediment can actually get moved a pretty far ways away, and even big boulders can actually get moved pretty far ways away. But then what happens is when that glacier melts, that material literally just drops out of the glacier, right where it is. We can also have mountain stream environments, which mountain stream environments are different because they're definitely operating under gravity, and they're highly subjective to different amounts of water depending on the year or depending on the type of season. So again, right, if you're at a mountain stream in the summer, well, you're probably going to have a much higher competence in discharge than, say, you would during the winter. We could also have an alluvial fan, and an alluvial fan is just where we've got water that's moving downhill from the mountain, and once it hits the flat part of the land at the base of the mountains, the water velocity is going to change, and now that river can't carry as much material because the water is moving much, much slower than it had previously. We can get sand dune environments, which obviously the transportation mechanism here is wind. And of course you can see those big crossbeds in this preserved sand dune, again showing you the direction that the wind was predominantly blowing from. We can also get our generic river environments, which river environments you're going to see in Chapter 17 are incredibly complex creatures. Here, this is let me get a different color. This is our channel for an old riverbed, but riverbeds are very dynamic and deposits all kind of different sediment all the way across the river itself. We can also get lake deposits, and lake deposits, we're going to get nice fine sediment there, because even if we have a shallow lake or a deep lake, lakes don't move very fast. So as you can see in this picture, we've got nice, very fine sediment that's deposited in these nice, great layers. And then we have our deltas, and deltas are just generically where sediment's piling up, where rivers are draining into lakes or rivers are draining out into the ocean, and it's due to that velocity change. So deltas, like I said, where our rivers enter the sea, and basically what's happening is my water velocity is slowing down, and all of that sediment that water was carrying just gets deposited right down here. And it's going to build up the land, right? So as that sediment is being brought out to the ocean, all it's doing is making that land much bigger. Moving out into the marine environments, we can get beach sand, right? Coastal beach sands, which again, this is very mature sand, so it tends to be very well sorted, well rounded, and it tends to be predominantly composed of quartz. And of course, you can see here those nice oscillation ripples showing as my water is moving in one direction and then the other direction. Moving out a little bit further, my water is moving even less and less, so my particle sizes become smaller, and I tend to find sand and silt out here. So we tend to find lots of shale, so you can see these nice thin layers from the weight of the water. Sometimes out there in my shallow marine, we can get these carbonate environments, which is where we're going to form coral reefs. So again, if I'm in that warm, shallow water environment, I can get these beautiful limestone banks getting deposited out there. And then as I go into the deepest part of the ocean, I'm going to get the finest sediment size, so I'm going to get clay deposited out there. But I can also get lots of microorganisms. So as they die in mass death laters, usually due to a slight change in temperature of the water, these organisms here, these are called coccolithophores, settle down to the bottom of the ocean floor and get compressed over time and form different rocks like chalk.